In this project, I'll show you how to create a simple contact sensor. This is a binary sensor that will only tell you whether or not a contact has occurred between the sensor and any other objects in the simulation. We'll build this project using the joint angle tutorial. So if you've not gone through that one, I suggest you do it first so that you have the base file to work with. Let's start by opening up that project and then resaving it as contact sensor. Next, let's add a ground surface so we'll have something to contact. To make it easier to see what's happening, let's add a texture to the ground. Copy the checkerboard bitmap from C, Program Files, AnimatLab, Bin, Resources into your project directory. Now change the color of the ground to white and set the texture to be the file that we just copied. Next, open the body plan for the organism and move its position to be 6 centimeters above the ground. Change the root body's rotation back to 0 degrees so that the arm is moving up and down. This will allow it to strike the ground. Now change the height of the root body to 5 centimeters. Next, let's add a box contact sensor to the arm. Set its rotation to be 0 for each axis. Set its size to be 1, 5, and 1.2 centimeters. Then let's set its local position to be 4.6, 0, and 0 centimeters. Finally, change its name to be ground sensor. It's important that the ground contact sensor extends slightly beyond the arm so that it can contact the ground. If it was inside the arm, then the sensor could never contact the ground and we would get no signal. Now let's go back to the behavioral editor and add a new normal neuron. Change its name to be ground. Now add a rigid body node and change its name to be GS for ground sensor. Connect the two nodes and change the adapter's name to GC adapter. Select the rigid body node and set its body ID to be the ground sensor. This associates our physical sensor to this node. Next, select the adapter and notice that its input source type is contact count. This will essentially be 0 or 1. A contact has occurred or it hasn't. So let's open up the gain editor and set the slope of the linear gain function to be 20 nanoamps. This means that if a contact is detected, 20 nanoamps of current will be injected into the neuron. If no contact is detected, then no current will be injected. Now, let's go back to our line chart and add an axis to show the firing frequency for our ground neuron. Finally, we need to reverse the velocity signals of our motor stimuli. This will make the arm hit the ground more so that we can see the contacts more quickly. Change the 0.2 radians per second to be negative and the negatives to be positives. Now let's run the simulation. Once the sensor touches the ground, current is injected into our neuron and its firing frequency shoots up to its maximum value. This demonstrates how you can add a simple contact sensor to your simulation.